Well, hi everyone. Okay, we're going to work on this practice test answer. So, number one says find the equation for the ellipse with foci at -2, 8. So, like -2, 8, and 6, 8. Alright, so this is 8 here. So these are the foci, and covertex at 2, 10, so like right around here. So we're talking about an ellipse. If these are the foci, or they are inside the ellipse, and there's the center. The center, if we take the average, the center, or use the midpoint for these, -2 plus 6 is 4, divided by 2 is 2. So the center is at 2, 8. All right, so find an equation for the ellipse. The center is at 2, 8. So I'm going to go ahead, and I know that we have, since this is on the same horizontal line, it's a horizontal ellipse, so the x's will come first, and we'll go x, where's my center? X minus 2 squared plus y minus 8 squared, and then equals 1. All right, now the covertex is 210. 2.8 to 210, that is b, and that's 4 units. Sorry, that's 2 units, and 2 squared is 4. Now, I don't know where the vertices are at this point, so what we're going to do is know that b is 2, distance from the center to a focus is 4, so that's the c value, and c squared equals a squared minus b squared for an ellipse. So c squared is 16, a squared we're looking for, and we're going to put the answer right there, minus b squared, which is 4. So when I add 4 to both sides, I get 20 is a squared, and that's where that goes. And number 2, find the equation for the hyperbola with foci at -8, 4, -8, -4, okay, just kind of get a point of reference here, and -8, 12. So these are the foci. And vertices at -8, this is 12, -8, 8, and -8, 0. So these are the vertices. And that's going to be part of my box, if I know where those are the vertices. Okay, and I know that it is going to be a vertical. So this is a hyperbola. Let me get the center now. It's halfway between the vertices or halfway between the foci, either way, and I think you're going to find -8, 4 is that midpoint between those two. And so we're starting with the y, so I'm going to do y minus 4 squared minus, and then x plus 8 squared equals 1. So you got to have the minus, the plus right here for the ellipse, the minus. Okay, now c is 8 units. It is the midpoint to the focus. A is vertex to the focus, and that's 4 units. C squared equals A squared plus B squared. So that is 64 equals 16 plus B squared. And I think you'll find B squared is equal to 48 when you solve that. So let's put the 48 here. The A, let's A squared, put the 16 there, and then we've got our answer. All right. Now number 3. I'm going to try to be very careful with this. I'm going to get everything except this on the left side. So I need to add 72x. So let's go 9x squared plus 72x. I'm going to add 25y squared to both sides. Go plus 25y squared. And then have this minus 150y. That equals negative 144. Now we got to complete the square. 9 times x squared plus 8x. I'm factoring out 9 plus blank plus 25 is a common factor there. And y squared minus 6y plus blank is equal to negative 144 plus 9 times that amount plus 25 times that amount. Okay. 8 divided by 2 is 4. 4 squared is 16. Negative 6 divided by 2 is 3. Negative 3. Negative 3 squared is 9. So let's put the 16 here and the 9 here. And I have 9, and then x plus 4 squared plus 25 times y minus 3 squared equals, now this is 144, this is 225, so those cancel, equals 225. So I'll go through and I'll divide by 225, both sides. I'm distributing it there. Now 9 times 25 is 225. So if I divide top and bottom by 9, I get x plus 4 squared over 25, and y minus 3 squared, divide by 25 on top and bottom, over 9 is equal to 1. All right. So I'm going to go ahead and graph. This is an ellipse because of the plus right here. And it's going to be horizontal. So 4, or negative 4, 3. So I'm going to put an axis here. And maybe here. I'll draw my x and y axes like that. Now, the center is at negative 4. 1, 2, 3. Negative 4, 3. And the vertex, we go 5 units on each side. 1, 2, 3, 4, 5. So I'm at 1, 3 here. 1, 2, 3, 4, 5. And I'm at negative 9, 3 here. And then the covertex would be 3 units on either side of the center. 1, 2, 3. 1, 2, 3. Okay, now let's draw our nice ellipse here. Okay, so there's my ellipse. Now this is a squared and this is b squared, and c squared is equal to a squared minus b squared for an ellipse. So I got 25, not there. I have c squared equals 25 minus 9. C squared equals 16. C is equal to 4. So 1, 2, 3, 4 units here. 1, 2, 3, 4 units here. It looks like my foci are at 0, 3, and 4, 5, 6, 7, negative 8, 3. So those would be the coordinates 1, 2, 3, 4, 5, 6, 7. Yeah. Okay, so there are the foci. Now, this one, we got to write the conic section equation in standard form and graph again, and just determine it. Do we have a hyperbola or an ellipse? We're not worried about parabolas in this test. So I'm going to start with 9y squared minus 36y, get the y terms together, minus 4x squared minus 8x, and I'm going to add 4 to both sides, equals 4. And now I'm going to complete the square. 9 times y squared minus 4y plus blank minus 4 times x squared plus 2x plus blank equals 4 plus 9 times blank minus 4 times blank. Negative 2 squared is 4. Put a 4 here. 2 divided by 2 is 1. Squared is 1. Put a 1 here. And I've got 9 times y minus 2 squared minus 4 times x plus 1 squared is equal to 40 minus 4 equals 36. And I will divide by 36 throughout. 9/36 is 1/4, so this is y minus 2 squared over 4 minus x plus 1 squared over 9 equals 1. Okay. And this one has a center at negative 1, 2. Right, I'm going to draw x-axis here. No, that's a y-axis. And y-axis, okay, this is the x-axis. All right, you know what I mean. So negative 1, 2. I'm going to make the box now. And also the vertex is 2 units up. That is a vertex. I'm going to go 2 units down to the other end of the box. That is a vertex also, negative 1, 0. And then the other side of our box, 1, 2, 3, so that we can draw the diagonals for the asymptotes. 1, 2, 3's right there. So I'm going to make the box so I can draw good asymptotes. It is, the y is first, so it is a vertical hyperbola. Hit that vertex right there and then come toward the asymptotes. I'm going to highlight this. The highlighted part is the actual hyperbola. All this other stuff is just guidelines for making a good hyperbola. All right, so I've got it graphed. I need to get the foci. A is 2, B is 3, c squared for hyperbole equals a squared plus b squared, which is 4 plus 9. So c squared equals 13. C is approximately 3.6. All right, so I'm going to go 1, 2, 3.6 here. 1, 2, 3.6 here. And this point is negative 1, 1, 2, 3, 4, 5.6. And this point is negative 1, negative 1.6. These are the foci, the coordinates of the foci. All right, determine the measurements of two coterminal angles, one negative, one positive, for the angles given. All right, guys, this is in degrees. If I add 360, negative 87 plus 360, I get degrees. I get 273 degrees. And if I subtract 360 degrees, I get negative 447 degrees. All right. 2 for 7 pi over 18. If I subtract 2 pi, I'd have 7 pi over 18 minus 36 pi over 18, converting 2 pi. 7 minus 36, that's negative 29 pi over 18. And if I take 7 pi over 18 plus 36 pi over 18, the 2 pi, I get 43 pi over 18. There's one positive and one negative. Now, converting negative 210 degrees to radians, remember that pi radians equals 180 degrees. And we don't usually write the radian unit out if we're using pi. Okay, so the conversion, I need the degrees to cancel out because I'm converting it to radians. So if I have the degrees on the bottom and put the pi on the top, negative 210 pi over 180, those will cancel. These are divisible by 3, so it's negative 7 pi over 6. Now, 5 pi over 6 radians. Now, radians is kind of on top, so I want radians on the bottom here and 180 degrees on the top. The pi's will cancel out. I'm going to divide by 6 here and divide by 6 here, and that's 30, and I get 150 degrees. Now on number 5, 271.35 degrees, we want to change to degrees, minutes, and seconds. So I'm going to take 0.35, 35 hundredths of a degree, and times it by 60 minutes, because 0.35 times 60, that's equal to 21 minutes, exactly 21 minutes. And I didn't finish this thought, because 60 minutes is a degree. So 35 hundredths of a degree is the same as 35 hundredths of a minute. So we got 271 degrees. 21 minutes there. And then if we go the other way, 11 seconds is 11/60ths of a minute. So I'm going to change 11/60ths to a decimal. 11 divided by 60, 0.183. So I have 38 degrees and 20.183 minutes. Now, I'm going to take 20.183 and divide that by 60. And that is 0.336, 38.336 degrees. This part right here is 0.336 degrees. Add it to the 38 degrees that you have. And there we have it, guys.